Now Alicia will use her model to estimate whether the macro population density is likely to fall below the minimum value required for sustainable fishing. So this was the whole point of the question. During the first 9 years, guys, that is important, and 5,000 obviously is important. So it says use Euler's method to sketch the trajectory of the phase portrait from 4 to 7 for M, 1.5 to 3 for S in the first 9 years. So I've put this here, guys, 4 to 7, M on the x-axis, and 1.5 to 3, which is S on the y-axis. Now, essentially, guys, what he's asking us to do is to sketch these points. So these are the points, and we're going to sketch them for 9 years, because this is only 1 year. So I need to go, I'm going to drag this all the way down to 9 years. Now remember, it's 10 is every 1 year, because we're going up in 0.1. So I need to go down to 90, and I may as well go a bit more than 90, just so we're clear. Okay, yeah, because it was always going to be 91. So essentially what we're going to do, guys, is sketch all these points. This is a point, this is a point, this is a point, this is a point, and there's 90 of them. But in an exam, or not an exam, I don't want to have to do that. I don't want to have to sketch 91 points. So what we'll do, and I think it's reasonable, and to be fair, whoever designed the question, I imagine this is what they expected everyone to do, is you'll just plot the points for every year. Just go from when t is 0, when t is 1, 2, up to 9. But certainly start off with this 5.72. So the 5.72 is going to be 5.72, something like that. Next point, we go to t is 1, 6.1, and 2.1. So that's 6.1, 2.1, a little bit increase in both the mackerel and the sharks. Then we go down to 2, 6.3, 2.4. Notice I'm rounding out to one decimal place. 6.3, 2.4, 6.3, 2.4, something like that. Down to 3. That's basically 6 and 2.7. 6, 2.7. Now notice we're starting to go backwards now. The mackerel are dying. 6, 2.7. So the mackerel are starting to die. Down to 4, 5.4, 2.7. 5.4, 2.7 is the same height, about that. Then down to 5, 5.1, 2.4, 5.1, 5.1, 2.4, something like that. Down to 6, 5.2, 2.1, 5.2, 2.1, something like that. Down to 7, 5.6, 1.9, 5.6, 1.9. Now note, guys, this is gonna, it looks like it's spiraling out. Let's continue. 6.1, 1.9, or it's nearly 2, so 6.12, 6.1, 6.12. Let's do that. And last one, 6.4, 2.3, 6.4, 2.3, something like that. And now I have to join them the way I said them. So as I said, guys, it's a spiral. Could have done better there, but whatever. So what's happening, guys, is the mackerel and sharks are both increasing, and then we get to this point here, and then the mackerel are right, okay, there's too many sharks, the mackerel start to die. But the sharks are still increasing, and then we get to a point here where it's like there's not enough mackerel, the sharks are starting to die, then the sharks die, and then we get to here, and it's like, oh, the mackerel go great, there's not that many sharks, so the mackerel start to increase, and we go on this kind of spiral thing. So That is part 1. Part 2, part II, using your face portrait or otherwise determine whether the mackerel population density would be sufficient to support sustainable fishing during the first 9 years. Now, guys, this is the key. Look, 5,000, it's mackerel, 5,000 is the minimum in the first 9 years, and this is what's happening in the first 9 years. Now, notice none of these points were less than 5. So the answer to the question is yes, as mackerel, how do I spell mackerel? Mackerel density never falls below 5,000 per kilometer cubed. You can say, if you want, as seen by vertical line on face portrait. Okay, finally, part 3. This is the last question of the paper. State 2 reasons why Alicia's conclusion found in part FII might not be valid. So there's quite a lot of things you can write down here, guys. If you check the mark scheme, I think they've got about 10 different things they'll accept. The obvious ones to go with are the parameters. The parameters were just estimates. That was one. Do you remember they gave us the values of alpha, beta, gamma, and delta? Well, they were just estimates. And then the second one is Euler's method. Euler's method is an approximation. Always remember that with Euler's method. It is a numerical approximation method. Approximation. And not perfectly accurate. But as I say, guys, there's lots of different reasons you can write down, but make sure you have 2, because it says state 2 reasons. Okay, that, guys, is the paper finished. So I'll see you in your next video.